For generations, scientists and dreamers alike have been captivated by the mysteries of Mars. The red planet has long been a subject of fascination and wonder, and for good reason. So are you ready to join NASA on the journey to discovering life on the red planet? Strap in and get ready for an unforgettable adventure as we explore the science, technology, and challenges of NASA's Mars mission. Watch the video now and discover the incredible potential and excitement of exploring the red planet. What is Mars? Mars is the fourth planet from the Sun and has a distinct rusty red appearance and two unusual moons. The red planet is a cold desert world with a very thin atmosphere. But the dusty, lifeless, as far as we know it, planet is far from dull. Phenomenal dust storms can grow so large they engulf the entire planet. Temperatures can get so cold that carbon dioxide in the atmosphere condenses directly into snow or frost, and Marsquakes, a Mars version of an earthquake, regularly shake things up. Many missions and research it. The first person to observe Mars with a telescope was Galileo Galilei in 1610. In the century following, astronomers discovered the planet's polar ice caps. In the 19th and 20th centuries, some researchers, most famously Percival Lowell, believed they saw a network of long, straight canals on Mars that hinted at a possible civilization. However, these sightings proved to be mistaken interpretations of geological features. Why is Mars called the red planet? The bright rust color Mars is known for is due to iron-rich minerals in its regolith, the loose dust and rock covering its surface. The soil of Earth is a kind of regolith too, albeit one loaded with organic content. According to NASA, the iron minerals oxidize or rust, causing the soil to look red. Mars surface. The planet's cold, thin atmosphere means liquid water likely cannot exist on the Martian surface for any appreciable length of time. Features called recurring slope linea may have spurts of briny water flowing on the surface, but this evidence is disputed. Some scientists argue the hydrogen spotted from orbit in this region may instead indicate briny salts. This means that although this desert planet is just half the diameter of Earth, it has the same amount of dry land. The red planet is home to both the highest mountain and the deepest, longest valley in the solar system. Olympus Mons is roughly 17 miles, 27 kilometers, high, about 3 times as tall as Mount Everest, while the Valles Marineris system of valleys, named after the Mariner 9 probe that discovered it in 1971, reaches as deep as 6 miles, 10 kilometers, and runs east-west for roughly 2,500 miles, 4,000 kilometers, about 1/5 of the distance around Mars, and close to the width of Australia. Scientists think the Valles Marineris formed mostly by rifting of the crust as it got stretched. Individual canyons within the system are as much as 60 miles, 100 kilometers, wide. The canyons merge in the central part of the Valles Marineris, in a region as much as 370 miles, 600 kilometers, wide. Large channels emerging from the ends of some canyons, and layered sediments within suggest that the canyons might once have been filled with liquid water. Mars also has the largest volcanoes in the solar system, Olympus Mons being one of them. The massive volcano, which is about 370 miles, 600 kilometers, in diameter, is wide enough to cover the state of New Mexico. Olympus Mons is a shield volcano, with slopes that rise gradually like those of Hawaiian volcanoes, and was created by eruptions of lava that flowed for long distances before solidifying. Mars also has many other kinds of volcanic landforms, from small, steep-sided cones to enormous plains coated in hardened lava. Some minor eruptions might still occur on the planet today. Many regions of Mars are flat, low-lying plains. The lowest of the northern plains are among the flattest, smoothest places in the solar system, potentially created by water that once flowed across the Martian surface. The northern hemisphere mostly lies at a lower elevation than the southern hemisphere, suggesting the crust may be thinner in the north than in the south. This difference between the north and south might be due to a very large impact shortly after the birth of Mars. Mars moons. The 2 moons of Mars, Phobos and Deimos, were discovered by American astronomer Asaph Hall over a week in 1877. Hall had almost given up his search for a moon of Mars, but his wife, Angelina, urged him on. He discovered Deimos the next night and Phobos 6 days after that. He named the moons after the sons of the Greek war god Ares. Phobos means fear, while Deimos means rout. Both Phobos and Deimos are made of carbon-rich rock mixed with ice and are covered in dust and loose rocks. They are tiny next to Earth's moon and are irregularly shaped since they lack enough gravity to pull themselves into a more circular form. The widest Phobos gets is about 17 miles, 27 kilometers, and the widest Deimos gets is roughly 9 miles, 15 kilometers. Earth's moon is 2,159 miles, or 3,475 kilometers, wide. Both Mars moons are pockmarked with craters from meteor impacts. The surface of Phobos also possesses an intricate pattern of grooves, which may be cracks that formed after the impact created the moon's largest crater, a hole about 6 miles, 10 kilometers, wide or nearly half the width of Phobos. The two Martian satellites always show the same face to their parent planet, just as our moon does to Earth. It remains uncertain how Phobos and Deimos were born. They may be former asteroids that were captured by Mars' gravitational pull, or they may have formed in orbit around Mars at roughly the same time the planet came into existence. Ultraviolet light reflected from Phobos provides strong evidence that the moon is a captured asteroid, according to astronomers at the University of Padova in Italy. Phobos is gradually spiraling toward Mars, drawing about 6 feet, 1.8 meters, closer to the red planet each century. Within 50 million years, Phobos will either smash into Mars or break up and form a ring of debris around the planet. Mayores facts: size, Mars composition, and 220 miles, 6,791 kilometers, in diameter, far smaller than Earth, which is 7,926 miles, 12,756 kilometers, wide. The red planet is about 10% as massive as our home world, with a gravitational pull of 38% as strong. A 100-pound person here on Earth would weigh just 38 pounds on Mars, but their mass would be the same on both planets. Atmospheric composition, by volume. According to NASA, the atmosphere of Mars is 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen, and 0.08% carbon monoxide, with minor amounts of water, nitrogen oxide, neon, hydrogen deuterium oxygen, krypton, and xenon. Magnetic field. Mars lost its global magnetic field about 4 billion years ago, leading to the stripping of much of its atmosphere by the solar wind. But there are regions of the planet's crust today that can be at least 10 times more strongly magnetized than anything measured on Earth, which suggests those regions are remnants of an ancient global magnetic field. Internal structure. NASA's lander has been probing the Martian interior since touching down near the planet's equator in November 2018. Measures and characterizes Marsquakes, and mission team members are tracking wobbles in Mars tilt over time by precisely tracking the lander's position on the planet's surface. These data have revealed key insights about Mars' internal structure. For example, the planet's core is 1,110 to 1,300 miles, 1,780 to 2,080 kilometers, wide. Observations also suggest that Mars' crust is 14 to 45 miles, 24 and 72 kilometers, thick on average, with the mantle making up the rest of the planet's non-atmospheric volume. Chemical composition. Mars likely has a solid core composed of iron, nickel, and sulfur. The mantle of Mars is probably similar to Earth's in that it is composed mostly of peridotite, which is made up primarily of silicon, oxygen, iron, and magnesium. The crust is probably largely made of the volcanic rock basalt, which is also common in the crust of the Earth and the Moon, although some crustal rocks, especially in the northern hemisphere, may be a form of andesite, a volcanic rock that contains more silica than basalt does. Mayores polar caps. Vast deposits of what appear to be finely layered stacks of water ice and dust extend from the poles to latitudes of about 80 degrees in both Martian hemispheres.